Let S be the set of all strings of zeros and ones, and let L be the set from S to the set of all non-negative integers. Those are the integers greater than or equal to 0. By the definition, L of S equals the length of S for every string S in S. Is L one-to-one? Now, one-to-one means that all of the outputs are unique. There's no way that you can get the same output with different inputs. So is there a way to get the same length string using different strings? Well, imagine L of 1001 and L of 0110. These are two different inputs. They're two different strings. And they're also strings from the set S because set S contains the set of all strings of zeros and ones. And here are some examples of strings of zeros and ones. Now, in this case, both of these outputs are 4, even though the inputs are not equal. And so this is not one-to-one. In this class, it's super easy to prove a function is not one-to-one, and it's super easy to prove that a function is not onto. It is way harder to prove a function is one-to-one and to prove a function is onto. Let's move on to part B. Is L onto? Meaning that is every non-negative integer here an output of the function? Well, consider an element from that set. So let's let lowercase z be in the set of all non-negative integers. So z is a non-negative integer. We don't know what it is, but it is a non-negative integer. Or put another way, z is an integer that is greater than or equal to 0. Now the question is, can we think of a string that we can plug into this function L that gives us specifically the output z? And the answer is yes. Imagine we take the string of zeros, 0, 0, dot, and then 0. And then how many zeros are here? Let's assume that there are z zeros. So if z is 5, then there would be 5 zeros. If z is 10, then there would be 10 zeros. Well, in this case, the output of this would be, according to the rule of this function, the length of the string, which is z. And so no matter what z is, we can find an input to this function that we can plug in that gives us the output z. And so this function is onto. Thanks, everyone, and I'll see you in the next video.